Hi guys, welcome back. I know you're probably oh, miss, I really don't want to. I know, I do apologize. Lesson 17 was a little much, but lesson 18 is a breeze. Lesson 18 is a cool breeze. Alright? So, we're going to talk today about functional groups. And the thing you need to know about functional groups is once we add another element to our hydrocarbons, we no longer have a hydrocarbon. It's now an organic compound. So, functional groups is an atom or group of atoms that replace hydrogen within a hydrocarbon and give the organic compound unique characteristics or properties. Right? So, for us to be able to identify, today all we're doing is identifying functional groups. That's all we're doing. Identifying functional groups. For you to be able to do this, you need to be able to turn to table R. Table R is your best friend. So I'm going to go ahead and click over. I'm going to go to my table R here. Once again, this unit, organic, is very based on the reference tables. If you have it, it makes your life a whole lot easier. Right? So, these are our functional groups. So with this table and our functional groups comes class of compound. Now, our functional groups are what get attached to the hydrocarbon. Our class of compound is the name for the functional group. So there's two different things, and it's very important because some of the questions will be like, what is the functional group? That's when you have to tell me the elements that are attached to it. When it says identify the class of compound, that's when you have to give me the name. Two different things. This table is really helpful because it gives you the class of compounds, so it gives you the names of the functional groups. Then it gives you the actual functional groups, the elements that get added to it. It gives you a general formula to follow, so what it should look like in a structural setting, in a structural diagram, and then it gives you the condensed formula as well as the name. It gives you an example. Now, the examples are very helpful. I find them very helpful because just in case you forget how to name something, you can always come to the example and then follow what it does. So this table is very useful. So for our class of compounds, we have the halide. Halides are group 17 elements that can get attached to a hydrocarbon. So once they get attached, the name of the hydrocarbon changes, and we now add a new prefix. So our new prefix would either be fluoro for fluorine being attached, chloro for chlorine being attached, bromo for bromide being attached, and ido for iodine being attached. So if you see F, Cl, Br, or iodine, they're attached to a hydrocarbon, the class of compound is a halide, and the beginning part of the name would be the beginning part of the name will have a new prefix. For an alcohol, we're going to see an OH, an hydroxide, an OH attached to our hydrocarbon. Now, this can either be at the end, the beginning, or the end, or on the top, or in the middle. It can be anywhere in the structure. I know your reading is going to be like, it can only be at the beginning, at the end. It can be anywhere in the structure. But as long as you have that OH, right? Now, when it's in the condensed version, obviously it's going to be at the end, but the structural version, it can be all over the place. Now, how do I know by just the name that I have an alcohol? I have an OH functional group? Very easy. The end of my name, instead of it ending in an E, like it did in alkane, alkene, alkyne, it's then going to end in an OL. So I'm going to have an O. So that's how we get methanol. That's how we get ethanol. That's how we get propanol. All of that. Then we have an ether. An ether, the functional group, is an oxygen that's going to be in the center of your hydrocarbon. The oxygen is going to be in the center of your hydrocarbon, and it kind of splits your hydrocarbon into two branches. So an ether, it kind of splits your hydrocarbon into two branches, and it's oxygen right in the middle of your structure. Now here comes aldehyde and ketone. Very similar. I like to call them siblings because they look very much alike, but the only reason that they're different is because of where they are placed, right? So for aldehyde is smack dab in the middle of sorry, aldehyde is smack dab at the end or the beginning of your structure. It's a terminal. So it's either the beginning or the end of your organic molecule, right? And I know it's a aldehyde because I have a carbon that is double bonded. We see these two dashed lines right here. Double bonded to this oxygen at the end or in the beginning. I also know that I have an al, I know I have an aldehyde when the ending of my name is a AL. So that's how we get propanol. That's how we get methanol. That's how we get ethanol. It ends in a AL. For ketone, its sibling, ketone is a little bit different because ketone will be in smack dab in the middle of our molecule. Ketone will be a carbon double bonded to an oxygen smack dab in the middle of our molecule. Ketone, the name ends in a 1. So instead of an E, we have -one. So that's how we have methanone or pentanone or ethanone, that type of thing. It ends in a -one. Organic acid and esters are also siblings. Let me not call them siblings. They're also cousins, let's say. So organic acid, we're going to have a carbon. The functional group is a carbon double bonded to an oxygen and single bonded to an OH. Now, what happens when it's time to identify an organic acid is some of you only see the carbon double bonded to an oxygen, or some of you only see the carbon single bonded to an oxygen and hydrogen. So you're either going to tell me it's a ketone or it's a alcohol. False. Right? That's false. Organic acid is a double bonded to an oxygen and single bonded to a hydrogen and an oxygen. And it's also a terminal. It's also a terminal element, a terminal functional group, meaning it's going to be the beginning or the end of the molecule. Esters are my favorite because esters create perfume. Esters, also like organic, are double bonded to a carbon, an oxygen double bonded to a carbon, and then single bond to just an oxygen. And this is also going to be in the middle of our structure. It is going to be in the middle of our hydrocarbon that's no longer a hydrocarbon. It's going to be in the middle of our organic molecule, right dab in the middle. Once again, don't mistake it for a ketone. Look at the overall structure and identify what makes it different. Amine, we see a nitrogen right in the middle of the structure, right? And then amide, we see a carbon double bonded to an oxygen, also attached to a nitrogen and a hydrogen. That will be at the end of the structure. So that is also a terminal functional group, right? Now, when it comes to this, once it comes to this, identifying the functional group and knowing what the class of compound is what we're focusing on. That is the most important part. So let's go ahead and practice that. Everything that I just said, I've just broken it down here. So I'm going to give you a few minutes to read that over. I also talk about the naming. We're really not going to focus that much on the naming. We're not going to focus that much on the naming. If we had more time, we would focus more on the naming. All right. So let's go ahead and see what type of functional group is attached right here. So I'm going to look at the overall structure and I see here, right? That is what makes a difference. Always ask yourself, what makes it different from a regular hydrocarbon? And that's what you have that makes stands out. So I see a carbon that's double bonded to an oxygen and a hydrogen. So that's when I go back to table R and I look. I'm looking for a carbon that's double bonded to an oxygen and single bonded to a hydrogen. So I know it can't be a halide because I have none of these elements. It can't be an alcohol because I just don't have OH. It can't be an ether because I don't have an oxygen right smack dab in the middle of my structure. Could it be an aldehyde? Well, I do have a carbon that's double bonded to an oxygen, single bonded to a hydrogen, but why not a ketone? Oh, I remember. A ketone is in the middle of the structure, while aldehyde is at the end of the structure. So that means that this is a aldehyde. Hopefully I spelled that right. Alright, so let's look at number 2 over here. Number 2, I'm looking at this overall structure. This is the only thing that makes it different. Oh, sorry. This is the only thing that makes it different. So I have a carbon that's double bonded to an oxygen. Carbon double bonded to an oxygen. Let me look at table R to see what type of functional group and what is the class of compound. So once again, can be aldehyde. Sorry. Once again, it can be halide, can be alcohol, can be ether, because none of them have a carbon double bonded to an oxygen. Aldehyde has a carbon double bonded to an oxygen, but I'm not bonded to a hydrogen. I'm bonded to another carbon. So that means if I'm not aldehyde, that means I'm a ketone. So, and ketone, usually right here when you see that blanks, it means that it's attached to another carbon, not a hydrogen. So this would be a ketone. All right. I have my structure. I see I have a carbon double bonded to an oxygen, also single bonded to an OH. Now, once again, I'm looking at the overall functional group that's been added to the molecule. I'm not just looking at part of it. I'm looking at all of it. So I need to find a carbon double bonded to an oxygen and single bonded to an OH. I'm going to go back. Well, it's not a halide. I don't have a fluorine, chlorine, bromide, or iodine. Alcohol, yes, I do have an OH, but it's just not an OH. I still have a carbon that's double bonded to an oxygen, so it can't be that. Ether, I have no oxygen, smack dab in the middle. Aldehyde, I do have a carbon that's double bonded to an oxygen, but I'm also attached to an oxygen and a hydrogen here. That's not there. Ketone, I do have a carbon attached to an oxygen, double bonded to an oxygen, but there's no OH here, so that can't be it. So, organic acid, I do have a carbon, double bonded to an oxygen, and single bonded to an OH. So that means my compound is an organic acid, because I don't want to write organic acid. I'm going to just write OA. Alright, so let's go ahead and let's try these practice problems out. I'm going to pause for a second and let's see if you can get it. Alright, I'm back. So, hopefully, you've realized that a couple of these are repetitive. So, let's do this. Number 2, okay, I see the number 2 over here. We have a Br. That's different from this compound. And I know that when I looked at table R, if I have a Br, that means I have a halide. Alright, if I go to number 3, even though that this is an alkene, because I have this double bond right here, I still have this Cl that's attached to my organic molecule. So if I had to identify the functional group, well, if I have a Cl, I know that if I have a Cl attached to it, that means this is also a halide because Cl is part of the halogen family, group 17. Alright, number 4, alkane. I see that, but I see that it's attached to an OH. Well, according to table R, an OH by itself is an alcohol. Okay, I'm going to squeeze one more into this. Alright. So I have, over here, I have C double bonded to an O, then I have an OH, and it's at the end. So I know it can't just be a ketone, because a ketone would be smack dab in the middle. An aldehyde, it cannot be because I don't have a hydrogen here. So that means this is an organic acid. Alright, last one. Because I have a Br attached to right here, that means that this, as according to table R, is a halide. Alright. Hopefully this was helpful. If you guys have any questions, let me know. And I'm here to help. Have a great day, guys.